Hey everybody, this is Mathventures, and today I'm going to give you my solution to the question that I asked in my previous video about this game where we put 8 cards face up on a table and we select exactly 4 of them such that their sum is a multiple of 4. And once we've selected those cards, we take them out and put 4 new cards in their place, and we just do that over and over and over till we can't stop. And my question was, can we do this over and over and over till we can't stop, or at least till we get to the bottom of the deck, or does there exist a combination of 8 cards where within those cards I can't find 4 of them that add to a multiple of 4? So I played this game, and my intuition was, yeah, you could probably always do it. I didn't seem to have any trouble finding a combination in each of those cards. Actually, sometimes I did. It was a struggle sometimes, but you could always find a combination of 4 when I played it. And so I believed that you could always do it. But that's just intuition, and that, while that's good, I'd like to prove it, because proving it is always better. And so I started thinking, what types of cards could we add together to get a multiple of 4? For example, we could add together multiples of 4 all day and still get a multiple of 4. And so we could add any of these multiples of 4 in the deck to get a multiple of 4. A queen is a 12, just so you know. And so if I add together any of these cards, I always get a multiple of 4. And if you're talking about multiples of 4 in a deck, there's really 4 possibilities. It's either a multiple, or it's got a remainder of 1, 2, or 3. And so I tried to fit the rest of the cards into these categories of the remainders. And so I put aces in this category because ace is 1. 5 has a remainder of 1 when divided by 4. 9 does as well, and king does too, because that's 1 more than queen. So I continued doing this. I got 2, and then I got 6, and 10, and that's all. There's nothing greater than king, and so I kept going. So within the 3 category, remainder of 3, I had a 3, a 7, and a jack. And if you noticed, within a deck of cards, there's 13 different numbers, and here's all of them. And they all fall into one of these categories, 0, 1, 2, or 3. And like I said earlier, if you add together multiples of 4 in any sort of combination, you'll always get a multiple of 4. So if you add together 0 plus 0 plus 0 plus 0, you always get 0. You always get a multiple of 4. And likewise, I tried to experiment some more with adding these and seeing if it always worked out. And it always does. If you add together ace, or 1 plus 3, or 1 plus 7, or 1 plus 11, you get a multiple of 4. 9 plus 3, 9 plus 7, 9 plus 11, so forth. Any combination of these cards, like if I wanted a card that was 1 extra, I would add together, 3 plus 1 plus 1, 2 of these adding to one of these. Anyway, so now that I have 4 different numbers instead of 13 different numbers, that makes life a whole lot easier. I really only need these 4 numbers to tell me whether the card is a multiple of 4 or has a remainder of 1, 2, or 3. And so now that I know that, life's much easier. And after that, I thought, well, what combinations of these numbers, these numbers will give me a multiple of 4 if I combine 4 of them? And I thought of the obvious ones first, 0 plus 0 plus 0 plus 0. You can add together 4 numbers which have a remainder of 1, because if you join all those remainders together, you get a 4. Get a multiple of 4. Same with 2, 2, 2, 2, and as you may have guessed, 3, 3, 3, 3. And if you don't find this convincing, please add together some of these 4 times in a row and you will see. Okay, that's not all of them though. I'm just going to make some more room. We also have 0 plus 0 plus 2 plus 2, right? Or 0 plus 0 plus 3 plus 1. And I tried to come up with more of these, and continuing patterns really helps in math sometimes. So I just tried to give it a shot. I increased each one of these by 1. So 1 plus 1 plus 3 plus 3. That adds up to 8, a multiple of 4. And let's try that one more time. 1 plus 1 plus 0 plus 2. Okay. And then I came up with a couple more, I'm pretty sure. I had 1 plus 1, no, 1 plus 3 plus 2 plus 2. Because 1 and 3 add up to a multiple of 4, and 2 and 2 do. And so I continued this pattern like I did earlier. I did 2 plus 0 plus 3 plus 3. And I found that that's all of them. I tried to find some more, and I realized I'm just getting the same ones, but in a different order. And so these are all 10 possible 4-card combinations, which will give you a multiple of 4, if we're just using the remainders. Which is nice now, because now I know what strings of numbers will give me a multiple of 4. And I noticed something about these strings in particular, that they all have a pair within them that repeats. Whether it's a 0, a 1, or a 2, all of them have at least one pair. Some of them are repeated all the way through, but that's still at least one pair. And so that's another useful thing that I noticed. And so now I'm ready to try to construct a hand where it won't have any of these in there in any sort of order. Let's use blue. 3, 4, 5, 6, 7, 8. Okay. So since we have 4 different types of cards with 8 slots, they're going to have to repeat because we don't have 8 different types of cards. So at least one of them is going to have to repeat. Let's just assume that it's 1. You could choose 2 or 3. It'll all work out the same, or 0. But let's just choose 1, okay? So we're halfway to making this hand right here, and this one right here, and this one right here, where it's all 1s. So what we don't want, if we want to construct a hand that doesn't have 4 cards, like I said earlier, we don't want to have 2 1s in there in some sort of order, or 2 more 3s in there, or a 0 and a 2 in there, intermingling. But to fill up the rest of the slots, those are my only options, 0, 1, 2, or 3. And I thought, how can I not finish off these remaining pairs? And I thought, well, if I just choose one number from each pair, I won't be completing the pair, so I chose a 1 and a 3. And with the 0 and the 2, I have a choice. It turns out it doesn't matter, but just for fun, let's just take 0. You'll see why it doesn't matter in a bit. So now we're fine. If we add together any of these cards, if we choose 4 of these cards, none of them will ever add up to a multiple of 4, which is nice. So now our next option is, well, we can't have a 1, because that'll finish this hand. We can't have another 3 in there, that'll finish this hand. And we can't have a 2 in there, because that'll finish this hand. My only viable option right now is 0. So let's put that down, see how that goes. 3 plus 1 is 4, plus 0 plus 0. That's a multiple of 4, which means that all 4 possible combinations that I could have put in here will give me a multiple of 4. And whether you start with a 2 or a 0 or a 3 as your repeated thing that has to be in there for a fact, you'll end up doing the same thing. So, you pick the 3 cards that have the pair of 2s in there, and it's the exact same thing we just did. We have these leftover pairs that we can't have in there, but then you realize that that's the only possibility. And so what I learned was that this game, you can always find 4 cards within 8 cards that'll add up to a multiple of 4. You just have to look real hard sometimes. But you can always do it. And in fact, even if you take out some of the cards of the deck, you can always do it then too, which is nice. You could play this game with an incomplete deck if you want. Anyway, so that's that. I've proven that you could always find 4 cards in a hand of 8 cards that'll add up to a multiple of 4. If you have any other problems or questions or something that you'd like to talk, or that you'd like me to talk about on the video, then that's cool. Just submit it in some sort of way to me. I don't care. And yeah, I'd love to talk about it. Thanks very much for listening, and stay cool.